I'll introduce you.
Okay, next talk is Gordon Henderson, and he's going to talk about FUZE, and he's going to talk about how to use BASIC in the classroom.
Hello everybody. Shut the door okay. BASIC is quite an old programming language. It's almost exactly 50 years old. At the end of April, beginning of May, was the 50th birthday of BASIC. So BASIC's quite old. I'm going to sort of show you a modern slant on old BASIC, but the first thing I'm going to do is I'm going to run a little thing up here. Now, this is a standard Raspberry Pi. This is a fuse box. You probably can't see it, but there's two guys over there, and there's a stand outside with FUZE, F-U-Z-E. You know, nobody can spell FUZE right these days, so F-U-Z-E. It's basically a classroom-ready box, big metal box. It'll hurt your foot if you drop on it, which I've done once, so I'm not going to do that again. Standard Raspberry Pi inside. You've got a GPIO breakout box. You've got a nice little breadboard to do some GPIO experiments on it. It's kind of self-contained, a nice little keyboard. I'm using a separate keyboard in case you wonder why. It's because I find it difficult to use that when I'm standing up. I've just got a little flat keyboard here, which is much easier to use when I'm standing up. So I've launched, started the Raspberry Pi. The graphical interface that you saw there is something called XFace. It's not the default one that comes with the Raspberry Pi. It's my own preference. That's all. But we're now inside the BASIC environment, and what I want to do is just do that, and then just give you a few bits and pieces. Bread. Now, I'm not going to use PowerPoint. This is a PowerPointless presentation. It's written in BASIC. Why not? You know. So there you go. And as you can see, you know, it's a bit retro. It's a bit oldie-fashioned. And we're going to go through. So, what is BASIC? BASIC, it stands for Beginner's All-Purpose Symbolic Instruction Code. What does that mean? I haven't got a clue. I think it just seemed like a good idea at the time. 50 years ago, they were in Dartmouth College in New Hampshire, over in America, and they thought, what can we do? The language at the time was something called Fortran. Fortran had been around for a good few years. Fortran is still widely used today in the scientific community. Why, I don't know, it just seems to be that way. But the people who were there, they wanted an easy way to teach computing. They wanted something that was interactive. To do your Fortran program 50 years ago, you'd have to type it on punch cards, or you'd have to write it on coding sheets and give it to somebody who put it on punch cards. They'd then put it through the computer, and you'd get the results a day later, if you were lucky. So what they wanted to do was they wanted something that was interactive and easy to use. Now, fast forward 50 years. Does anybody recognise this man? Well, this man at the front might recognise it. His name is Alan O'Donoghue, and to quote something out of a book that's 30 years old, you will learn more of his wisdom later. In a recent blog post, Alan wrote this, and the idea was basically, as I understood it, was not to concentrate on any one language for teaching. Now, my interpretation of this is the first 2 years of secondary school, which I think is years 7 and 8 in English terms. I've been living in England for 25 years, and I still get confused about the English school system. So we're talking about the 2 years of general education in secondary school before the young people select the GCSEs and go on to specialise in something. So we need something that's going to engage the young people. We need something that's going to remove the boredom factor, because bored children in the classroom are hard to manage. And something that's easy to use, something you can play with and have fun with, I hope. You can go to Alan's blog, and Alan, if you hang around for Alan's talk, which is in about an hour's time, I think, he'll give you pointers to his blog and everything else. Anyway, these are sort of five key words, phrases that Alan sort of mentioned in his blog. The important one, I think, for me is the problem-solving one. Programming for me is all about problem-solving. You've got a problem, you need to solve it. Is that problem how many grams of flour do I need to put in my bread versus how many grams of water? That could be a problem of some sort. We could write a program to do that, or we could write a spreadsheet. But that's what we want to do. We want to talk about problem-solving and how we do it. And I think that's the end of this little thing here. Yeah, it's the end of this. Has anybody here programmed in BASIC before? One or two people have put their hands up. Probably at least 2/3 of the audience. Now, a lot of things you'll hear about BASIC. BASIC is bad. BASIC encourages bad programming. BASIC has this horrible go-to statement. BASIC is this, that, the other thing. And yeah, 50 years ago, that's what BASIC was like. And I'm going to show you an example. Sorry, I have to turn around. We don't have anything at the front here. It's going to give me... This is a program which I've written to simulate flipping a coin. This is the interactive environment I was telling you about. You can type commands at it, you can run the program. Okay, that's a slight goof on my part. It's to do with the font sizes. Yeah, there you go. Can you all read that? Yeah? That's a great monitor. So we run the program and it says heads. We try again, we get yes, it says tails. We try again, it says heads, and so on and so forth. Now, there's the program. Now, if you're as old as I am, which I'm sure none of you here are, then you'll recognise that that's a basic program. It's a bit old-fashioned. What we've got there is we've got this wonderful go-to statement. So if C equals 0, then go to 100. These line numbers here are our line numbers, and you'll see here there's a line 15. You can make your numbers go up in any number you want. It starts at the top, it goes in ascending numeric order. That's old-fashioned BASIC. There's two go-to statements there. If you try and follow the code through, you see that it jumps from the top to the bottom and back up to the middle again, and it jumps. So it begins to become a little bit difficult to understand. That's old BASIC. That's why people say today that BASIC is not suitable for today's world. BASIC encourages bad programming habits. If you've got a good teacher, which I had, then the teacher can tell you how to avoid these bad programming habits. And there's another chap that I'm sure you've all heard of, Eben Upton. His first programming language, BASIC 2. And what did he go on to do? Design the Raspberry Pi. So, you know, if you get the right environment, you can learn and you can see through the issues surrounding BASIC. But today we've got young people who've got tablets that swipe, and they want colour, they want glitzy, flashy things. So we can improve on that. So if we go back to problem solving, what would if we solved the problem of bad programming? The first thing, if we sort of think, well, if you take away the line numbers, what happens if you take away the line numbers? You can't have a go-to because you can't go to a line number. So what you've got to do if you take away the line numbers is you add a few extra things in. And so to manage it, we're going to have a look at this program in a slightly different format. This is the same program, it does exactly the same thing, in a slightly different format. Look, we've got colour now as well. So, a couple of things we've introduced. This thing, cycle repeat. That's not part of old BASIC, it's a part of my new BASIC. That basically gives us a repeat loop. I'm using indentation. Indentation, unlike Python and Occam, is not mandatory. So the two languages that require indentation, Python and Occam, you probably haven't heard of Occam. If you have, then great, but don't worry about it. They require indentation. In BASIC, it's entirely up to you. You can indent, you don't have to. It makes it look nicer, I think, if you do indent. We've got a nice little screen editor here that we can go around and do things. The program does exactly the same thing. Now, hopefully, if you're showing people this sort of level of programming, you'll already have done variables in Scratch. Maybe they've got a good idea of variables, so you can then equate the same thing to here, where we've got, you know, coin equals random2, which, you know, we've got different style of comments here, which is a more modern form of comments. You know, we've got multi-liners then else's, and we've got this cycle repeat to bound the whole thing. So already, we've taken away line numbers, we've added a couple of extra things in. This now makes it much more similar to a modern programming language. Now, anybody who's programmed in Pascal C, Java, PHP, Python should be able to just read that and understand it. There should be no great issues there. I mean, the one thing that BASIC's got is it's got two variable types. One is a number, and one is a string. Strings have got the $sign after it. So basically here, where it says input try $, that just tells the system that it's a string rather than a number. That's the only variable type that we've got here. This runs exactly the same way. I can run it from the editor. Tails. You go through the whole thing. tails. It's just where you work out how random the random number generator is heads. Tails, more tails than heads. I'm not sure why, but there you are. You can lead on from that, and maybe you could maybe try and get young people. I'm just using this as an example. They say, well, what if we want to flip a coin 1,000,000 times? Great, let's write a program to flip a coin 1,000,000 times. I'll just get out of that. There we go. Oops, that's number one. What happened? I couldn't see what I was typing. It said no such file or directory. And that's because it's not spelled like that, it's spelled like that. So I get for trying to type without looking at the screen. It's the same program, but we've added an extra loop round about it, and we've added an extra bit of printing. So counters, heads and tails, how many times, the for loop, again Basic's got a for loop, it's had a for loop for the past 50 years. The RTB and FUZE versions of Basic, it's got one loop, which is cycle repeat. So anytime you see a loop in here, you use cycle repeat, modified by for, while, until. And it's the same program, we've just made it a little bit bigger, and we can run it from the environment. 1,000,000 flips on the Raspberry Pi takes about half a minute. It's not that fast. It's fast, but it's not that fast. So there we go, 10,000 flips, and it's veering a little bit towards heads. So if you're a betting man, maybe if you're getting the Raspberry Pi to flip a coin, you might want to flip heads. But then again, sometimes if we do it again, there we go. Yeah, I see. It's a little bit more heads again. You know, so I don't know. I've run this. I've experimented. Sometimes it's one way, sometimes the other. But that's random numbers for you. There's a whole science involving random numbers if you ever get into it. So that's simple programming. That's the difference between traditional old Basic and sort of modern FUZE and RTB basics here. So a nice editor to do it. So I'll just show you one or two other things. I'm just going to show you some examples of Basic, and because I know that out there are similar examples in Python. If I can remember the file names, because I forgot to bring in my cue card with the file names on. Let me have a look. Let's have a look at that one. Turtle Graphics. Who here knows about Turtle Graphics? Yeah, great. I'm just after I left school in the 80s. Logo was a language that was touted as learning in schools. Anybody here heard of Logo? Yeah, Logo is where the Turtle Graphics sort of originated. Really, I thought it was great. I wrote a program in Basic that ran on an Apple II to act as a Turtle Graphics interpreter. It took 20 seconds to execute each statement. And that was on an Apple II 30 odd years ago. So here's you've seen the standard. The square. It's way down at the bottom there. Yeah, there's the program that draws a square. It is not difficult. I was teaching some young people last year, and I went through them. I put young people out there and said, we're going to draw a square, take 3 steps, turn 90, take 3 steps, turn 90, so repeat. And I got them to do this in Scratch, and I actually got them to do move, turn, move, turn, move, turn, move, turn, and then I introduced them to loops, because you say programmers are lazy. I mean, as a programmer, I'll be the first to admit that I'm lazy. So you then introduce them to loops, and then you condense the loops down. So when I did it in Basic, I did exactly the same thing. I got them to type out 8 lines of move right, move right, move right, move right. And then when they got bored of typing that, I said, well, this is how you do loops in Basic. So the standard for loop. For counting 1 to 4, cycle, move right, move right. And using that, you can build on that. I mean, I'll just kill myself here. Let me just put this back again. Right. We can build on that. We can. Oops, I've hit the help button. I don't need help. Maybe I do. That was square 1, square 2. Maybe I should have checked that I shouldn't have been running it on a big monitor. But the you then have 1 loop, 2 loops, loop inside a loop, and you can use builder. I love Turtle Graphics for this because it's very visual and it's instant as well. You can actually type these commands in. If you really want to here, you can type in HGR, which initializes all your graphics. pen colour equals yellow, and then pen down, and then move 100. So you can do all this interactively, and that's one of the things that you can do with BASIC. You can type things in, you can see them on the screen, you can turn them into programs, you can use the interactive environment to examine variables, you can set variables as well. I think it makes it quite an easy to use environment. Let me just one more go on that. Ah, there we go, look. You can even do animations. When I did that on my BASIC system, that would have taken about an hour, 30 years ago. So this is, do you all know how to generate that shape in Total Graphics? You draw a hexagon, and then you turn 60 degrees, and then you draw another hexagon, and then you turn 60 degrees, and then you draw another hexagon, you turn 60 degrees. It's that. It begins to get a little bit indented, a little bit more complex, but it's still there. It's immediate, and it's in front of you, and it's going on. So I think we'll leave that as it is. We can do all the rest. We can have a look at some of the other things outside later if you want to have a look at. Now there's one thing on the Raspberry Pi. So we've got graphics straight away. You can do Cartesian graphics. You can do Total Graphics. There's a three-dimensional graphical output device built into the Raspberry Pi. Well, it's not built in. It's a package that you can load onto it. Anybody guess what that is? Minecraft! Hey! Has anybody here used Minecraft on the Raspberry Pi? Yeah, one or two people. Yeah, this is great. And it's a game, but if you view it as a three-dimensional graphical output device, you can build things. You can start to learn about three-dimensional coordinates. Minecraft lets you fly around it. You can fly around it, and you can see what you're building almost in real time as you're doing it. And this BASIC talks to Minecraft. I'm going to very quickly. How am I doing for time? Because I forgot. 5 minutes. Okay, 5 minutes. We'll see if we can just very quickly do this. I've just come out of that BASIC. I'm going to start up Minecraft here. Let's just see what happens here. Start game, world. With a bit of luck, I may have actually flattened this world. If I haven't. Oh, yes, I have. There we go. So there's Minecraft. Let me just get out of it. Let me just load up BASIC. This is RQB, which is not the FUZE branded version. It's exactly the same as the FUZE BASIC at the moment with a different logo at the top. Load Minecraft. We can do things like, actually I'll just go, since we've already loaded that. Here's a little program. I wish I could type. Okay, with a bit of luck, yay, it's going to start raining. If I go over to the Minecraft window and click, we'll see, yeah, there's a rain. Oh, there's a clock there as well, so that's left over from the last time. So this is a little program, and it follows you. So if we, let's just go over. Fly away. You can't run away from the rain because it's going to follow you.
You're living in England too long.
I live in Devon. You know, it rains even more in Devon. On the edge of Dartmoor where I live, it was raining this morning. So let's escape from that. Go back to here. Escape from that. Have a quick look at this program in the editor. That's the program. It doesn't. That's basically it. So that's how you do it in BASIC. Very similar to Python. If you look at the Python Minecraft interface, it's very similar to it. It's sort of deliberately similar to it. So Minecraft Connect and localhost here. If you're not too good on networking, localhost is you, local computer. If you know the IP address of the person sitting next to you and they're playing Minecraft, you can connect to their Minecraft and destroy their world. Wouldn't recommend it in a classroom situation. It tends to get a bit noisy at that point. So trying to control Minecraft in the classroom, I've found it's been somewhat challenging. Fun, but somewhat challenging. Get tile, that's a command inside the Minecraft world. It gets the tile that you're standing on as an X, Y, Z coordinate. We know that y is our up and down coordinate, so we're going to go 30 blocks above, add 30 onto y. X and y, let's just go sort of random plus or minus 15, which is what that's doing. And set block rain type. So the rain type here is gravel. If you're not too familiar with Minecraft, Minecraft doesn't have very good physics. There's only 2 blocks that really obey the laws of physics in Minecraft. Gravel is one of them, sand is another. So you can try water. I started off, I'll make it water, but what happens is you get columns of waterfalls and it gets really, really slow as it tries to keep the thing going, and it's slow. So we're there with Minecraft. We can write Minecraft. We can write programs that use our sort of 3D coordinates in Minecraft. We can use Turtle. We can use 2D graphics. We've got an interactive environment. It's basic, an adjunct, not an alternative, but something to use alongside Python, Scratch, and so on in the first 2 years of secondary school, where the young people are learning a text-based programming language. I don't know. It's out there. It's available to you. You're the guys who are teaching this. It's up to you, really, at the end of the day. So, questions? None. Great. Go home. Go back to Devon. But it rains.